Okay, so just as a quick review, we have two quadratics here. We have f of x and we have g of x, and we want to figure out which one has the greater y-intercept and which one has the greater vertex. So for which one has the greater y-intercept, well, if you look at these, remember your y-intercept is where you intersect the y-axis, and that means that x is a value of 0. Sorry, that's hard to see. So when x is a value of 0, there we go. On this f of x graph for right here, and on g of x for right here. So obviously we don't have specific coordinates, but we can tell that here we would assume that g of x has the greater y-intercept because it sits higher on the y-axis. Okay, which quadratic function has the greater vertex? Well, if you look, f of x is a vertex up here, g of x is a vertex down here. Here they're just talking about the greater vertex, so we want to focus on that y value. So your y value of f of x is going to be higher than your y value of g of x. So in this case, f of x would be your answer. So these are the types of questions we're going to go through today. We're just going to analyze some functions and compare them, compare different parts of them, y-intercepts, coordinates, stuff like that. So on page 151 in your book, example number 1 says, which function has a greater y-intercept? F of x equals 8x minus 2, or g of x equals 2 times x minus 3 times x plus 1. The first thing we need to talk about is what we know about all y-intercepts. Well, for every y-intercept, we know that all y-intercepts have an x value of 0. Okay, and if we're talking about greater y-intercepts, that means the greater y-intercept will be sitting higher on the y-axis. And obviously vice versa, if they ask for the lower y-intercept or the smaller y-intercept or whatever, then it would be sitting lower on the y-axis. So if we look at our two functions, it says determine the y-intercept of each function. So you can do this one of two ways. You can use your calculator if you want to take these and you want to set it equal to turn in your y equals and all that. I'm going to clear my memory just because of all the work we were doing last week, and then I don't need to worry about if my plot's on or whatever. You could go into y equals and you could type in x, et cetera, et cetera. Or you could say to yourself, okay, I know that every y-intercept has the next value of 0 and do it by hand. That's what I'm going to do. So to find the x-intercept of f of x, that would be 8 times 0 minus 2, which is 0 minus 2. So you're looking at negative 2. So for f of x, you're at 0, negative 2. Now for g of x, make this a little smaller so I can see it. For g of x, here, we have 2 times 0 minus 3 times 0 plus 1. So that ends up being 2. 0 minus 3 is negative 3. 0 plus 1 is 1. 2 times negative 3 is negative 6 times 1 is negative 6. So you end up with 0, negative 6. So here, when it says compare the y-intercept of each function, well, remember they were asking for the greater y-intercept. So which one would sit higher on the y-axis? So f of x has the greater y-intercept. Okay. All right, so now that's how you do it with y-intercepts. If you look at example number 2, I'm going to make mine slightly bigger. There we go. You have 3 students shooting wads of paper, okay, with a rubber band aiming for a trash can in the front of the room. The height of each student's paper wad is given as a function in the time of siege. Which student's paper wad flies the highest? Well, if we're looking for the highest, that means we are looking for the largest y value overall. So no matter what the function, we want to find the largest y value overall. So if we look, the first one says the path of Alejandro's is modeled by that quadratic equation. So you have negative x squared plus 2x plus 7. And I'm just going to graph it in a standard window. Okay, so since it's a quadratic, we're looking for the largest y value. Obviously, we're going to find the maximum. So second calc max, you can do your left bound and your right bound and your guess. So the maximum for his is 1/8. Okay. For the next one, it says Melissa's paper wad is estimated to reach the heights shown in the table below. So they give you the x's and the y's. You can see it's quadratic because we have some symmetry here because it is a y value of 3, 6, 7, and then back to 6. That means this is your max height, that 3, 7. And then for the last one, it says after 3 seconds, Connor's paper wad achieves a maximum height of 6.5 feet above the floor. So his max height at 3 seconds is 6.5 feet above the floor. So if we look, the question's asking whose paper flew the highest. Well, Alejandro's went 8 feet in the air, Melissa's went 7 feet, and Connor's went 6.5 feet. So our answer would be Alejandro. All right, for example number 3, it says which of the following quadratic functions has a vertex with a larger y value? Okay, so again, we're looking at the vertex. I'm going to take that first one, and I'm going to put it in my calculator. So 2x squared minus 12x plus 25. Just graph it in my standard window and see if that's good enough. And it is. So here we have a minimum. So I'm going to calculate my minimum, my trace menu. So left bound, right bound, let's see. You gotta come down. There we are. Left. Go to the right of the vertex. You gotta give it that interval to look in. Hit enter. So the minimum value for f of x right here, let's try not using yellow, is 3, 7. Okay, so if we look at g of x, which is in the table again, here you want to look for your symmetry. So we're at 7, we're 8, we're back down to 7. So that means this, because we have symmetric points of 7 and 7, 3, 8 is going to be your vertex. So it's asking for the vertex with the larger y value. Well, the y value on f of x is 7. The y value on g of x is 8. That means g of x has the larger y value. All right, for example number 4, I want you guys to complete the work for this problem on page 150. It should be blank. We're gonna do 2 problems on there, so kind of think of your page in halves. Okay, so it says on example number 4, you are considering investing $5,000 in one of 2 mutual funds. The first fund will pay $500 each year. The second fund is predicted to have end of the year balances as shown in the following table. Which fund should you choose if you want to withdraw your money after 5 years? And then again, what about 10 years? So the first fund, if you look, we're putting $5,000 in both. The first fund is going to give you $500 each year no matter what, which means the first one is going to be linear because you have a constant rate of change. So in order to write an equation for that, well, we started with $5,000. And each year we are adding 500. So we need our variable to be with a 500 because that x is going to represent years. So we have y, or f of x, equals 500 plus 5, or 5,000 plus 500x, okay, where x is number of years. So the second one is in the table. So I'm going to look. Here, the table does go up to 5 years. So the second fund after 5 years has $7,000 in it. So if we look, after 5 years, this fund is going to have 5,000 plus 500 times 7. Sorry, I don't know what all that yellow is. So we have 500 times 7 plus 5,000. You're going to have $8,500. after 5 years. So for the first question after 5 years, fund, I'll just call it fund number 1, is better after 5 years. Now for the next question, it says, which fund should you choose if you want to invest the money for 10 years? Well, that's pretty easy over here because we were able to write an equation. So after 10 years, we could just do 5,000 plus 500 times 10. So that's pretty straightforward. And you're going to end up with a total of $10,000 after 10 years for the first fund. Now, if we go back to this fund, it doesn't go to 10 years, it just stops at 5. So we need to do some investigating here. If I look from year to year, here I get $200 after the first year. Here I get $300 after the first year. Then I add 400, and then 500, and then 600. So I can kind of start seeing the pattern develop. So I'm going to continue that chart over here for your X and your Y, X being years, Y being money. So 6 years, 7 years, 8, 9, and 10. Well, if you think about it, we added 100 more each time. So in year 5, we had $7,000. And then I would assume that we would add $700 to that. So this is going to be 7,700. And then, because we added 700, now we'll add 800. So we get 8,500. So we could probably stop there, but let's just keep going so you can see how this works. Then we're going to add 900. Then we're going to add 1,000, and so on and so forth. Oops. So after 10 years, you're going to have 11,500 in the second account and 10,000 in the first account. So while fund number 1 was better after 5 years, it looks like fund number 2 is better after 10 years. So all you're doing for the first one, we could be really concrete with our data, whereas in the second one, you kind of had to do some inferencing and figure out, well, what's happening in my table and how can I use that to figure out what's going on down the road. Okay. So same thing kind of when it comes to example number 5. So again, I'm going to do example number 5 on the bottom half of page 150. It's written in your book on page 152, so don't write it all down. Just make a note of where to find the problem. So it says, suppose that you've been offered a position in a prestigious company. You may choose how your salary is paid. Option 1 is described by the quadratic equation. S of x equals 2,500x squared plus 2,500x plus 60,000, where x is the number of years, and S of x, so y, is how much money you're making. Okay. Option number 2 has a yearly salary of $35,000, but you'll get a 25% raise each year. So here, you're going to make a table of values for each salary, and we'll use our calculators because they are asking 2 questions. If you plan to work for this company for 5 years, which option should you choose? And if you plan on working for the company until you retire at age 70, what option should you choose? So I'm going to use my calculator. The first one is given to me. So 2,500x squared plus 2,500x plus 60,000. Now, for the next one, that's given to us. But for option number 2, you have a yearly salary of $3,500 and you get a 25% raise each year. So option number 2 is going to be exponential. So your A value, your initial value is 35,000. That's what you're starting with. and you're getting a raise of 25% each year. So remember that B value, if you're getting a raise of 25% each year, you're making what you made the year before plus another 25% on top of that. So your B value is going to be 1.25 to the X. So the 1.25 is standing for the 100% is what you made last year, and then 25% on top of that. So 1.25. Remember, you're always comparing that to 1, which is 100%. So let's put that into our Y2. Okay. And I'm just going to go to my table, and so I can compare, because here it says, if you plan to work for this company for 5 years, which option should you choose? So remember, we have option number 1 in Y1 and option number 2 in Y2. So after 5 years, if you look in option number 1, you're making $135,000, and in option number 2, you're making $106,812. So after 5 years, option number 1 is the better option. Better as in you're making more money. Okay. You might want to make a note somewhere. Oh, hi. What the heck? There we go. You might want to make a note somewhere that we put both equations in your calc and compared, just so you know going back how we got our answers. Okay, so you put both equations in your calculator and you compared them in the table. So now we could easily tell, okay, after 5 years, option number 1 is better. Now, the next question says, if you plan to work for this company until you retire at age 70, what option should you choose? Well, it doesn't say how old you are, so you just have to do a little bit of inferencing. So I'm going to look at the table, and if you notice, right around 11 years, all of a sudden Y2 surpasses Y1. So option 1, all of a sudden you're not making as much money, which makes sense because option number 2 is exponential. So if you look at that point, after 11 years, option number 2 is going to be your better option. Now remember, when you get into these E's, that's times 10 to this. So now we're in the millions at this point, okay? So I'm going to assume if after 11 years, option number 2 is better, if I'm planning on working until age 70, I'm going to assume that it's going to be more than 11 years, okay, just by the context of the question. So if I'm going to work until 70, option number 2 is better for retirement. Okay. Just because at 11 years is that breaking point where option number 2 becomes the better option, and then it's always going to be the better option from there on out. Okay. So your homework tonight is just going to be doing kind of the same thing. You're just going to be analyzing functions and trying to determine what has better data for the given situation. Your homework is going to be on page 155. It's numbers 4 through 9. There it is. A little shout out to Indiana basketball. Homework is page 155 through 156, just numbers 4 through 9. It shouldn't take you very long. Okay.